You mean 31?
Oh, yeah, I'm sorry, guys. I meant 31. Thank you. I'll verbalize it in a minute in case y'all didn't hear that. Thank you for checking that. Okay, I guess our intercom's not going to kick on this morning. Sorry, I just now updated. I meant for you to turn in assignment 31, which was the book assignment yesterday. Most of you guys gave that to me yesterday, but if you didn't, you can still get full points, but I need it now, please. So a couple of you turned in number 30. I meant to say 31. I haven't taken up number 30.
So do we need to turn in 30?
No, you do not need to turn in 30. Just the book assignment 31 from yesterday if you didn't turn it in yesterday. All right. So for our unit 3, I told you that there's 2 big topics that take a lot of practice. The first being implicit, which we have spent the whole day on yesterday. So, of course, you will see that again on your review, and I'll give you a little more practice on implicit, but mostly we are moving on from that. The other big topic in Unit 3 that takes a lot of practice is related rates. And related rates are built upon some geometry formulas they expect you to know. So we're going to start off with handout 32 here, so that you know which geometry formulas you are expected to have memorized. Now, most of them are pretty basic, thankfully. Alright, so these are some of the more common ones that get asked a lot. Now again, not until the next handout can I show you how we're going to use these, but Pythagorean theorem, where C is the hypotenuse. So if somehow you don't have that ingrained in your brain, you need to relearn that. Formulas for area of a circle, we've got circumference and area. So they're expected. Your AP exam will not provide those for you on the AP exam, so I won't provide them for you on our test either. You need to know both of those if you don't. For squares, you need to know the area side times side, and the perimeter is just adding up all the side lengths. Again, you probably know that, but just in case you don't, I'm making sure you know that that's fair game. Okay, and then for the last couple, I want to give you, instead of just telling you what the formula is and hoping that you memorize it or still have it memorized, I want to give you a little bit of some insight on how you can find the volume of some 3D shapes without having to memorize everything. So, three-dimensional shapes tend to have one of two things. They tend to either be a prism, which just means they have 2 bases, like a cube is technically a prism because it's got 2 bases, a top and a bottom. And the volume of a prism is always capital B times H, where capital B is the area of the base. So a lot of times with the cube, we might say length times width times height. the length times the width is like the area of the base, and then that gets multiplied by the height. So anytime a three-dimensional shape has two bases, sides that are parallel to each other like that, top and the bottom, it will be area of the base times the height. So whether it's a square, prism, cylinder, whatever, it's got two bases, area of the base times the height. The other type of three-dimensional shape that comes up a lot is a pyramid. Pyramid is where you have a base, one base, and the other side is not a base, but instead just a vertex. These are almost the same formula. Area of the base times the height. So that's why a cone is almost pi r squared h. But there's one other thing. Do you remember what else you have to multiply by for volume of a cone?
A third.
Very good. So anytime it's a pyramid and you have just one base, it's the same thing, area of the base times the height, but times a third. A lot of times, knowing that, you can kind of figure out what you need just kind of in the moment. I don't memorize this. I don't memorize the volume of a cone. I know that cone has one base, so it's going to be area of the base, pi r squared, times the height, times a third, since it's a pyramid. If it wasn't a pyramid and instead a prism, I wouldn't multiply by a third. Area of the base times the height. The other big one is volume of a sphere, but they always give you the volume of a sphere formula. They don't expect you to memorize that. These are the ones that they do expect you to know and memorize to use. Okay, any of these you need to talk about before we move on? Okay, then the second thing we're going to do today is I need to tell you what a related rate is, give you some tips on how to solve them, and so we'll go over these, create a list of suggestions at the top there. Notice I didn't type them up for you because it should be dynamic, should be fit to what you think makes sense. Then I'm going to walk you through all of this one, and then I'll ask you to practice I think the circuit, the other handout today, has like 12 questions, so I'll ask you to try these. But you may remember me saying the last few days, related rates are probably my favorite type of question, especially for first semester, just because you're going to see that we can answer some pretty interesting real-world things that we could not do without calculus, and you already know enough calculus to be able to do these. So they're kind of interesting in that sense. All right, so question one. So again, just for this, just follow along with me. Make sure you guys speak up and interrupt me if you need to. All right, a certain calculus student hits calculus teacher in the head with a gigantic snowball. If the snowball is melting at a rate of 10 cubic feet per minute, at what rate is the radius changing when the snowball's radius is 2 feet? Okay, so for all of these questions, you need to try to find a geometry formula to start with. So there should be some hint in this. The shape of the object, the dimensions, the type of information they give us, which is how fast the snowball is melting, how is the radius changing when the radius is this length. So what shape is this talking about?
Sphere.
Okay, it's a sphere. We're assuming it's a normal ball, snowball. So you would need to start with the geometry formula. Now, sphere is the one you don't have to memorize. His volume is 4/3 pi r cubed. And the only reason I don't make you memorize it is because when they ask you to use it on your AP exam, and they will, they'll put it in the question. They'll put it in the directions. Okay, so the next part is we need to do calculus. So related rate, make sure you add this. Related rates are when you take the derivative of something with respect to t, time. As time moves, time is the variable we're interested in here. Or sometimes your hint will say that the function is a see what would be the best way to word that. A function in terms of time. That's how we would normally say it. So if you're asked to take the derivative with respect to time, or if you're told the function is in terms of t, time, so the next thing we need to do is actually take the derivative here. So same derivative properties, but you've got to make one big connection, and it's very similar to what we did with implicit. When we took the derivative of x stuff with x stuff with respect to x, we had a dx over dx, which doesn't change anything. The other thing we did in implicit is we took the derivative with respect to x of y stuff. And the problem is these two variables don't match. So you take the derivative the normal way, and since y is not the same thing as x, you need a y prime. So for this question, when I take the derivative of v, the derivative of the volume, with respect to time, all of these are with respect to time, v and t are not the same thing. So it would be 1 v prime. Just like the derivative of x is 1, the derivative of v is 1, but because v is not the same thing as t, we're doing v prime. Over here, we've got a number times r cubed. So do power rule on this, bring the power down, lower the power by 1, and then realize you just took the derivative of r stuff with respect to time. R and t are two different things, so you have to put an r prime. Every time you take the derivative of something with respect to another variable, you have to put that variable prime. Just like when we take the derivative of y with respect to x, we always put a y prime. Now we're taking the derivative of v with respect to time, so v prime. Derivative of r with respect to time, r prime. Yep.
You don't have to do anything with the fourth or spot.
That's the constant multiple rule.
Okay.
You can always just pull it out front and do the derivative behind that. Okay, so then what you hope is that all this information in here, so I started to underline it, but you're probably going to need to use all of this. If the snowball is melting at a rate of 10 cubic feet per minute, what is this describing?
How fast it's shrinking.
Okay, but
The rate at shrinking.
The cube.
it's the, let me erase this stuff. This was just real. This is the way volume is changing. Does that make sense? Okay, so 10 feet per minute. Okay, and purple, at what rate is the radius changing? So am I trying to find what r is? I'm not trying to find r. I'm trying to find r prime because I want to know the rate of the radius. And the rate of the radius, it changes at different times. If the snowball is really big, the radius is probably shrinking much quicker. If the snowball's super small, then it's probably not shrinking much anymore. But specifically when r is 2 feet. So we need to list out all the knowns. That's what I'm doing right here. I know how velocity is changing. I know what I'm trying to find. And I know when I'm trying to find it. And for the easier related rate questions, you're almost done. You're going to plug this stuff in over here. V prime. Actually, I'm wrong here. V prime is not 10 feet per minute. This would mean it's increasing. Since it's melting, I should have made this negative. Negative 10 feet per minute. This is just a number. This is just a number. Although times 3 divided by 3, let's just cancel those. Okay, what do I plug in place of r? Good. Big difference between r and r prime. Be careful there. R is 2, and I'm trying to find r prime. So on the easier related rate questions, you just plug in the stuff they give you, and you will have one equation, and the only thing that's missing is what they're asking you to find for this question. So you will need a calculator. 16. You don't need to get up and get it right now for the notes, because I'll do that for you. But the right side was 16 pi r prime, so I divided both sides by 16 pi. So negative 10 divided by 16 pi tells me that at that instant the radius is changing by negative 0.199. Okay, what kind of units do you think this would have?
Per second squared.
Close. Okay, if the radius is in feet, r prime is going to be feet, but r prime is a rate, so it can't just be a distance. It's got to be a distance per an amount of time. Minute. No, not squared. It's just feet per minute. Alright, so we found a geometry formula that matched this question. It was a sphere, so we started with volume of a sphere. We took the derivative with respect to time. Every time we took the derivative of something that was not a t, we created a prime version of that variable, plugged in all the stuff we had, and then the only thing missing was the one that they wanted us to find. So this is best case scenario, but you're going to hear that I'm going to try to format all these questions the same way, because the next question is going to have nothing to do with the sphere. It's not going to have anything to do with this formula. The derivative's not going to be the same. You're not going to have the same information. But there are consistent parts in these questions that we need to stick with. Okay, so number 2. A stone is dropped into Lake Fayetteville, causing concentric circular ripples. So that's like you drop a stone. Concentric circles just mean circles within circles. So another tip I would give you, I don't think you really need this for question 2, but you're going to see we're going to need this later, is sometimes draw a picture. I don't think you need to see the snowball in question 1, so it's not like it's an every question thing, but sometimes the picture helps. Okay, whose radius is increased by 2 meters per second, so that would be r prime. It's not how big r is, it's how fast r is changing, so not r prime. How fast is the disturbed area growing? So how is the area changing, a prime, when the outer ripple has a radius of 5 meters? So one consistent thing in all of these questions is you have to make an educated guess about what geometry formula we're supposed to use. So what type of geometry formula is going to include this type of shape with these type of variables?
A circle.
Okay, and what about a circle?
It would be
Circumference,
area.
So you got to find a geometry formula. You've got to take the derivative with respect to time. The derivative of a would be 1, just like the derivative of x is 1. But if you're taking the derivative of a with respect to some other variable, t, you need an a prime. Pi is just a number. R squared, you can do the power rule. You can bring the power down, lower the power by 1. And I just took the derivative of r stuff with respect to some other variable, so it's got to have an r prime. And if we're lucky, we just plug in the stuff where we need to and solve for what we need.
So the derivative of the area is just like circumference, technically?
Circumference is just 2 pi r.
Okay.
Yeah.
Never mind.
'Cause of the r
I
prime.
asked that question before you drew the R.
Actually, not today's worksheet, but there is a worksheet that we will look at next week where one of the questions has you do something like this and your answers in terms of circumference. So you're close there. But okay, so this is what I'm trying to find. So obviously I don't know it. I want to know when r is 5. In fact, I'm going to do units on this question because I want to show you and maybe convince you to keep up with units on all these. If r is 5 meters and r prime is 2 meters per second, it looks like a prime is 2 times 5 times 2 times pi, which is 20 pi. And notice if you keep up with units, what's meters times meters per second? So area is always squared units. Area could be feet squared, meters squared, miles squared, but if it's the rate of change of area, it's going to be units squared per time, per second, per minute, per hour. And notice, again, I know it's sometimes a pain, but if you actually write the units there, you can see meters times meters, meters squared over seconds, and then you don't have to do that mental thought. Okay, so again, maybe you're not impressed yet, but I mean, this is a question that you could spend all day just trying to mentally brute force, guess, and check. And you're probably not going to discover the area of that bigger circle is changing at this rate at that instant. But with just a tiny bit of calculus, we can calculate those things. Okay, let's keep going, because again, some of these will require a little bit extra effort. Sometimes you don't have exactly what you need. Sometimes you have to dig deeper for one more piece of information. All right, question 3. All edges of a cube bless you. So I'm drawing a picture, probably not necessary here, but are expanding at the rate of 3 centimeters per second. So I'm going to call all of these sides S. So S is changing at 3 centimeters per second. How fast is the volume changing? So do I want to know what V is?
Yes.
I want to know what the volume is?
Derivative.
Right. I want to know the rate, so that's V prime. When each edge is 1 centimeter. Okay, so you got to think about what shape are they talking about and what formula do they want me to try to pull in here. So this is one that I did have on your first handout this morning. A cube has a volume that is S cubed, side times side times side. Or you can think of it as area of the base, side squared times the height, side times side times side. It's going to be side cubed no matter how you think of it. Okay, and then I want to take the derivative of this. So what's the derivative of V?
3s s prime. 3s to the second power s prime.
Okay, y'all are ahead of me. The derivative of just V is V prime. Okay, how do we take the derivative of S cubed? Okay, power rule. I don't know why I did R there. Okay, why do I need an S prime for people who don't know why that's missing? Right, just like when we took the derivative of V with respect to time, you need a V prime. When you take the derivative of S with respect to T, you need an S prime. The only time you don't create a prime is when it's the same variable. If you're taking the derivative of X with respect to X, you don't need an X prime. If you were taking the derivative of T with respect to T, which almost never happens, you wouldn't need a T prime. Okay, and then this is what I'm solving for, so of course I don't know it. They told me S is 1 centimeter, and they told me S prime is 3 centimeters per second. Notice I'm writing my units down here. So in the end, 3 times 1 squared times 3 would be 9. Centimeters times centimeters times centimeters would be centimeters cubed. which makes sense. Volume is cubic units, and then it's per second. Okay with that? Okay, let's step it up one. These last three are a little bit harder. So we definitely need a picture here. These are very classic questions. In fact, I'll probably have you do a Khan Academy that's light question 4. These are the most common related rates on the AP exam. Your AP exam will ask you multiple different type of related rate questions, but this is one type that I can promise will be on there. We've got a 25-foot ladder that's leaning against a house. The base of the ladder is being pulled away or falling or whatever at 2 feet per second. How fast is the top moving down? How many feet per second is the top of the wall? How fast is the top of the ladder moving down the wall when the base is 7 feet from the wall? Okay, so picture was probably optional on the whole front page. Picture is not so optional on this page. Here's my ladder, 25 feet. It's leaning against a building. I can see it's being pulled this way. I like to put an arrow there so I remember. This, I'm trying to figure out this rate. How fast is this? Is it falling down the side of the building at this time when he's 7 feet away? So now that you have the picture in front of you, what's the geometry shape you think they want us to use?
Triangle.
Okay, it's
A squared plus B squared.
it's a right triangle. So it could be area of a triangle, it could be perimeter of a triangle, it could be Pythagorean theorem, but Pythagorean theorem's the big one. So I'll say a squared plus b squared equals c squared. This is calculus, so we're going to take the derivative of that. The derivative of a squared, you're going to do power rule. Just make sure you realize you're taking the derivative of a with respect to t, so you need an a prime. You take the derivative of b squared, same idea. Power rule, and you're taking the derivative of b with respect to time, so you need a b prime. Do it a third time for c prime, or for c squared, power rule, and then times c prime. C is not the same thing as t, that's why I need a c prime. Now, I'll be honest, I don't recommend this, but notice how all of these have a 2. You could divide both sides by 2. A lot of people just memorize this so that they can skip those couple steps because these questions come up so much. So, I don't know. I don't like you to memorize it just because I'm afraid you'll miss it. It's not necessary. Pythagorean theorem, take the derivative with respect to time, and then divide everything by 2 if you want to. Okay, so with Pythagorean theorem, just like your notes today, I said the hypotenuse has to be C. The other two could be A or B, doesn't matter. They're the legs. So let's just call this one A and that one B because it doesn't matter. Okay, so I'm going to ask you, I'm going to start to plug in these things and see how close we are to getting our answer. What is A in this question?
Oh, 7 feet.
The length of A is 7 feet. What is A prime?
We don't know.
2 feet per second.
We do know that. How fast? Because they told us how fast this is moving away. So 2 feet per second plus B. Okay, do I know the length of B?
No.
You can find it out.
Okay, I'll come back to that. So I don't know B, I'm going to leave it there. Do I know B prime?
No.
If I knew B prime, I'd be done, right? That's what we're trying to figure out. We're trying to figure out how this side's changing. So how this length B is changing in feet per second. So I don't know B prime. Okay, do I know C?
25.
Okay. What about C prime? It's 0. Why is it 0?
This is constant.
Right, your ladder's not changing in size while you're trying to use it. That would be crazy. but this one is not changing, so his rate is 0. That's just to be understood. Okay, so we get to this, and unlike the front page, I'm not finished because I can't solve this for B prime yet because I'm missing two things. I'm missing B and B prime. So of course, B is going to be the last thing we figure, or B prime is going to be the last thing we figured out, because once we know what they're asking for, we can quit. So sometimes you have to pause and then think of, I have to figure out some way to figure out how side B is, and it has nothing to do with this.
You just use Pythagorean theorem.
Right, and then within your picture here, I tried to make my picture look pretty decent looking since you're all looking at it. But at the end of the day, it's a right triangle where this is 7 feet and this is 25 feet, and we could use Pythagorean theorem to find this length, or it's a Pythagorean triple. 7, what, 25? Guess?
Yes. 7 squared plus B squared equals 25 squared.
That's correct. 24. Yeah, so you could use a calculator there, but I'm just, if you know Pythagorean triples. So when this length is 7 and this length is 25, this length has to be 24. So again, we didn't have to do that on the front page. I only do that if it's needed. But sometimes you have to take a step back and dig deeper to find one more piece of information, and then you can just solve normally. Our answer is going to be negative 14 divided by 24, which is negative 7/12. And the units there are feet per second. I don't have to put too much thought in the units because I listed it when I made my picture. If this was changing in feet per second, this is changing in feet per second. Okay, you okay with that? Okay, I'm sorry.
Do you have to do negative if it's speed?
You should not be putting any thought into your answer whether you should be changing it to positive or negative. The fact that this is negative or positive should be based on all of this. So the fact that this is negative means that it's going down, which makes sense in the context of the question. So, okay, so if we changed it to 15 feet from the wall, notice, still should do a picture. You still got a right triangle. You can still do the derivative. I'm skipping some of this because we're just changing one number. The only thing I'm changing is this is 15 feet from the wall. But C is the ladder. It's still 25. The ladder's length is still not changing. If I call this A, they're now changing it to be 15 instead of 7 like the last question. A prime is still 2 feet per second. We just figured out B was what, 24? Sorry? Very good. So be careful here. that's the only thing that's different about this question. B was 24 in the last question because it was a 7, 24, 25 triangle. But this is a different time. Now this ladder's further away. It's 15 feet from the wall instead of 7 feet from the wall. So now this is a 15 something 25 triangle. 20. So if they change that length, picture still helps, still Pythagorean theorem, still taking the derivative with respect to time, still plugging in the stuff that's given to you, still searching out one more piece of information. But in the end, our answer comes from negative 30 divided by 20. And that would be feet per second. Okay, so one more. So again, these are kind of just building up. Obviously, when you guys start the circuit starts off with pretty easy questions and builds up to these. Okay, the baseball diamond is 90 square feet. I think I need a picture here. Okay, CJ runs from first base to second base at 25 feet per second. 25 feet per second. That seems really fast. 25 feet in a second. Now, how fast is he moving away from home plate? So he's somewhere between first and second base. How fast is he moving away from home plate? So how many feet per second when he is 30 feet from first base? So when this length is 30 feet. Okay, baseball diamond's 90 square feet. He's running from first base to second base at 25 feet per second.
We need to find out what that is in miles per hour after we do this.
I'm sorry,
We need to find out what that is in miles per hour after we do this.
to see if it's very fast.
Yeah.
He's running like a 1.540. He's going 25 feet. Oh no, that's not true. Never mind.
I don't know, my brain doesn't work in that. It just seems fast to me.
So that's yards.
Okay, when he's 30 feet from base. So you don't have to do this, but notice how I underline stuff. That kind of helps me remember what I've considered and what I've not considered. So, all right, so there's our picture. Now that we've got a picture, we've got a good idea of what our shape should be. I know this looks like a square, but we shouldn't be using a square or a square formula in this question. We should be using what?
Triangle.
Okay, so what about a triangle? Area, circumference,
we're
or
trying to find the. We're trying to find C prime.
okay? So only Pythagorean theorem is going to do that. Area formula is not going to help you find the hypotenuse, speed, circumference of a how did I say circumference? Perimeter is not going to give you that. Area is not going to give you that. Okay, take the derivative with respect to t. So power rule, like you're used to, and a is not the same as t, b is not the same as t, c is not the same as t. So you need an a prime, a b prime, and a c prime. Feel free to divide everything by 2 just to make it look a little easier to work with, although you can do that later. And then let's start plugging in the stuff that we need. So hypotenuse has to be c. The legs can be a or b. One of the legs needs to be a, one of the legs needs to be b. I'm just naming them for us so that all of our work looks consistent. So all of this stuff didn't matter. I'm only really focused on this right triangle here. Okay, what is the length of A?
30.
Okay, what is the rate of change of A? Good. You see how this picture makes this a lot easier to plug these things in the right spot. Okay, do we know the length of B?
Yes.
We don't really,
30 feet.
We don't need it, do we? Since it's going to be times 0.
That's a good question. So first off, I don't know what B is. I think I could probably figure it out. But
I mean, B is 30 because it would be the same length as A.
But we're not going to. So then-
no. Why would A have to be the same length as B?
Because the distance between bases in baseball is consistent. If you're going around the perimeter.
That's true, but this 30 feet isn't the
Oh,
distance
when
from
you
first.
say-
That's how far that's just his distance away from first. Okay, so let's say we don't know what B is. Maybe we don't even care, who knows. But how is the length of B changing? It's not. It's 0. That distance isn't changing. Okay, I also don't know the length of C, and I don't know the rate of change of C. In fact, the rate of change of C is the whole thing we're searching for in this question. So I know that's kind of my last hurdle here. So 30 times 25 is 750 plus 0. I still don't have enough to solve for what they want but I still think it's worth just plugging everything in you have, because then it's super obvious what else you need to know. We need to know C before this is done. So notice we have the right triangle in this problem. We know this length is 30 feet. I don't know this length, I don't know this length, so that's a problem. So, since I've underlined everything, it's a little easier for me to see. I never used this. A baseball diamond is 90 square feet. How is that supposed to help me know the length of B or C?
Square is 90, so it could be.
Okay, right. So if this is a square, we know the area of a square is side times side. So the square root of 90, I don't think comes out great. Yeah, you could call it 3 root 10 would be better. But basically, if we know this is 90, we can figure out each side is the square root of that. And then once you know this is the square root of 90, or 3 square roots of 10, then you can do Pythagorean theorem. 30 squared plus 90 squared is supposed to equal C squared. So C is the square root of 990. So our answer is 750 over the square root of 990. About 23.837 feet per second. By the way, I always round to 3 decimal places. I don't know if y'all have noticed that, but just like we did in pre-calculus, because that's what your AP exam expects.
Would it not just be 90?
Oh, that's right. Yeah, you also have to add the square and the square root of 90.
One more time.
It's 750 equals square root of 990. Wasn't it in the square root of 90?
No, because you have 30 times 30 plus the square.
I just didn't show this. A squared plus B squared equals C squared.
Oh.
C was, yeah, I just did that in my calculator.
Oh, okay.
C was the square root of 990. So I did that on the side and plugged it in. So sure, you read this question, you have no idea this is what your work's going to look like. But you have an idea of what a baseball diamond looks like. You can draw it. You can label the information where you think it goes. Once you have that in front of you, you're probably going to see the geometry formulas, Pythagorean theorem. This is calculus class, and we are doing derivatives, so you know you're going to have to take the derivative of that geometry formula. You plug in all the information. Sometimes you're done, like the first couple questions. Sometimes there's one more thing you have to find, and it just depends on the question on how to go about finding that. But if you just write out what you have, write out the derivative, start plugging in the stuff you have, it should be painfully obvious what the next thing is you need to find. Trying to do it all in your head is way too much. All right, so again, that's what you will be building up to, of course. This is on the harder end for sure. But now I'm going to give you the rest of class, and I haven't done this circuit in a couple years, so I'm going to do it as well. I did a couple this morning before y'all got here. But to start the circuit, try it out, see how it goes, and hopefully have a pretty good understanding of related rates by the end of class. Again, related rates, even though you've seen the whole process, geometry formula, take the derivative, plug in given information, maybe find more information, solve for what you need. It's very consistent. The process is very consistent, but one question might be a circle, the next question might be a sphere, the next question might be a right triangle, the next question might be a rectangle. So for that reason, we spend a little bit more time on these question types. So. So I say that so that you know it's not, you'll have more than just a day to feel like you have perfected this skill. Also, if you've ever seen my poster right outside the door that shows like what elementary math looks like, what algebra looks like in the real world, what trig could look like in the real world, the calculus example is a related rate.
fast. Not like the fastest of like an athlete. It's about 17 miles per hour. So that's pretty fast for an athlete.
That's pretty, yeah. I don't think anybody in here is running 17
No.
miles per hour.
I mean, unless you're like a sprinter.
Does creatine help you run faster?
I guess not for me.
I mean, I'm thinking
Helps
of
you recover
comparing
from
it
running
to-
fast.
That it does.
So does water and sleep and food.
I'm thinking of comparing it to the Tyreek Hill reaching 23.24 miles per hour on the keeper turn.
Yeah.
Wow.
Like I said, especially if this is like thinking about youth baseball, which it probably isn't a concept that's very fast.
Distance from base to base 90 feet?
Huh?
Isn't the distance from base to base 90 feet?
Question one.
It probably
Yeah.
depends. Are you talking about pro field or?
Yeah.
Oh, I don't know.
Pro field, I think it is.
I think they shortened it recently, but
Baseball distance between bases, 90 feet.
yeah.
So I don't know. Maybe that's Little League or something.
Oh, because I tried to do that too.
Well, I was wondering if it meant like besides 90 feet or the whole bit.
So
This said 90 feet square.
plus HP.
Yeah. So our sides were
Yeah.
different. That's why I said maybe it's a minor league field or something. I don't know. That's not the point. It's a made-up question.
Yeah.
All right. Are you guys done with question 1 yet?
Yeah, you said it all right.
What did you get for an answer on number 1?
0.75.
That's what I got. 3/4 or 0.75. Anybody stuck with number 1? I will. Okay, rectangle's base. So doesn't matter which one you call base, and I think of length and width, but whatever. I'll call this the base. Stays 0.5 centimeters. Its height changes at 1.5 centimeters per minute. What rate is the area changing when the height is 1.5 centimeters? Okay, so what's the geometry formula you need to start off with? Okay, what's the derivative of this?
A prime equals B times H prime.
You took the derivative of this, then took the derivative of this, and then slapped a multiplication sign in between them?
Oh no.
If we could do that, we would have never had to learn the product rule. You got to take the derivative of this one with this one left alone, plus the other direction. Product rule still applies. Now notice, every time I took the derivative of A, I needed an A prime. Every time I took the derivative of B, I needed a B prime. Every time I took the derivative of H, I needed an H prime. And the reason why all of those needed a prime is because we're taking the derivative with respect to T. And A is not the same as T, B is not the same as T, and H is not the same as T. That's why those are needed. Okay, so I'd say that's probably the most common one, but the base, they said, is not changing, so B prime is 0, so whatever. The base was 0.5, the height is changing at 1.5, so your answer comes from 0 plus 1/2 times 3/2, which is 3/4, or 0.75. So question 2 is on the bottom of this page, and notice if you just glance at it, it looks like the same question. They just barely tweak it, and your approach is just a little bit different. Did this answer everyone's question about number 1?
If it's 0 times 1.5,
Mm-hmm.
how does that amount to anything?
It doesn't. This went to 0 plus 1/2
Oh wait, okay.
plus 3/10.
Okay.
Yeah.
I thought, wow.
I shared my answer to number 2, and a few more minutes from now I'll work it out if you need me to. Okay, if you still didn't get that as an answer on number 2, I will go over it with you. Okay, rectangle's base remains 0.5 centimeters. His height is changing at 1.5 centimeters per minute. I do like to at least put the units on my picture, because if I don't put the units here, I might think this length is 1.5 instead of the rate is 1.5. That would mess you up. Alright, at what rate is the perimeter changing? So perimeter of a rectangle, or the perimeter of anything, is like the distance around the whole thing if you walked all the way around. So 2 times the base plus 2 times the height, or length and width, whatever you want to call it, doesn't matter. So to take the derivative of p with respect to time is p prime. Derivative of 2b with respect to time would be 2b prime. And the derivative of 2h with respect to time would be 2h prime. Okay, p prime is what we're solving for, so I know I don't know that yet. I called this guy my base, and they said he's not changing. It remains at 0.5 centimeters, so his rate is 0. And the height is changing at 1.5. So it looks like 0 plus 2 times 3 over 2, which would give you 3. Now notice perimeter is a length, so it should be centimeters, miles, feet. When it's an area, it's centimeters squared, feet squared, miles squared. And of course, if it's a rate, you need per time, per minutes, per hours, per seconds, whatever the question calls for. Okay, everybody's okay with question 2? Three for 3. Okay, I think, as I said, I was trying to work these before class because I have not done this circuit in a couple years. Last year, that group just didn't do this circuit for some reason. I don't remember why. But, so I need to work a little bit myself here. And you are more than welcome to use a calculator on some of this. You don't need, the first couple I don't think you needed one, but if you need to come borrow a calculator, come help yourself. I did put the answer up to number 3 if you're not feeling confident. Okay. I think everyone's had time to get to 3 by now. Does anyone need to see 3 worked out to come up with that as an answer? 4.067. Okay, so we'll offer again here in a few minutes then.
Do you know if I've used the right equation?
For
The answer I got is
what number?
4, 5.
No, I just now started it. Give me just a second.
Okay, cool. Thank you.
Okay, offer one more time for number 3. Anybody change their mind about number 3 being worked out? Okay, and then number 4, I got an answer of 2.4. Anybody know they need to see that?
You work that one.
Sure. So this one is almost exactly the same as what we did on your notes, because again, this is one of the most common question types, but your picture doesn't have to be perfect, but it will certainly help. Alright, so I've got a 13-foot ladder. It's sliding down the wall at 1 feet per second. Now, I know one of the common things here is that if something's going down or left, that means it should be negative. So I had said a few minutes ago, don't worry about trying to change your answer to positive or negative. Don't be changing signs of your work at the end. But when you're setting it up, you do have to put thought into it. It's going down this fast. You should make this a negative one, not a positive one. Positive ones means it's going up that fast. So that's probably the most common mistake. Okay, when the ladder is 5 feet away. So here's our right triangle. Pythagorean theorem's the one that's going to tie all of this together. After I take the derivative of all of those and divide by 2, get to that. Still okay here? Okay, so this side has to be C. Hypotenuse has to be C. The other two are A and B. Just pick one to be A, one to be B, doesn't matter. So I know A is 5. I don't know A prime. That's actually what we're trying to solve for here. plus b, which I also don't know, times b prime, which is -1. So if we're lucky, this is ready to solve. It's only going to have the one variable that you want. But this one, it looks like I still need to figure out b before I can get this down to one variable. So within all of this mess, sometimes I just kind of resketch. I've got a 5 something 13 triangle, right triangle. So you can do Pythagorean theorem, or if you know your Pythagorean triples, you can skip. That is 12. And then from there, I just added the 12 and divided by 5. Again, you should not just be looking at your answer and deciding whether to maybe change it to negative or change it to positive. But it should make sense in the context of the question. The fact that this is positive means that this is increasing, and I feel like the lower that ladder gets, the faster it's moving away from the wall. So that makes sense that that's positive to me. If it was negative, it would be moving slower away from the wall. So the further out it got, it would just get slower and slower, like slow motion, which wouldn't make sense.
Why do you get just 13 on the other side of that? It's like, what do you...
Oh, yeah, I'm sorry. This was 13 times this. I forgot to put this in. C prime was 0, so all that goes to 0. Sorry. The answer came from 12 this. Sorry. Okay, you got what you needed out of that? Okay, was anybody else going to ask about 4? Need something specific there? Okay, then let's just quickly share 5. Okay, there's my answer to 5. Okay. No? No? Anything I can help with yet? Yeah, you probably didn't put parentheses for your fraction. Yep. I know that's going to happen to a lot of people today, but the other thing, so anytime you do a fraction in your calculator, the safe play is just put parentheses around the numerator, parentheses around the denominator, so that doesn't happen. Or you can do the alpha y equals 1. And then it lets you type it in like a fraction, and then it does the implied parentheses around the numerator and denominator. Probably what she was just saying right there. That's when you type this in. Yep. The way you type it in your calculator is wrong. But your calculator does order of operations strictly. So it does the division and then it's coming back and multiplying by pi. So it puts it in the numerator. Yeah, obviously when you guys are putting your answers in the calculator, you need to make sure you're typing it in the way you intend to. Your calculator does order of operations very strictly. So what I mean by that, on question 5, to get this as an answer, I typed in 32.5 over 10 pi. But if in your calculator you say 32.5 divided by 10 times pi, it's going to do 32.5 divided by 10 and then multiply by pi, which puts it pi in the numerator, not in the denominator. You need to make sure you either put the numerator and denominator in parentheses so that doesn't happen, or type it in as a fraction by doing alpha y equals option 1. Okay, I'll offer to work out question 5. Anybody need to see this one? Yes? Okay. Alright, you've got a circle expanding at this rate. Now, they don't come out and say whether that's area is changing or radius is changing, but the units should give you a hint. Radius isn't centimeters squared. Volume is not centimeters squared. Area has squared units. And since this is unit squared per time, I know that's the rate of the area. Okay, how fast is the radius changing? So r prime is what you're trying to solve for. And centimeters per minute if the circumference of the circle is 10 pi. Okay, so the geometry formula that pulls these things together would be area of a circle. The derivative of a with respect to time would be a prime. This, I would do power rule. Oops. And realize I took the derivative of r with respect to time, so I need an r prime. And to be honest with you, I took this and solved this for r. When circumference is 10 pi, I figured out that r was 5, but that was totally not needed. I think they were trying to do us a favor here. 2 pi r, which is circumference, is 10 pi. Oh, and they gave me a prime. So r prime came from 32.5 divided by 10 pi. And again, make sure that you're typing it in the calculator correctly, because that has been a common mistake. 2 people in a row this morning. That's what messed them up. They just didn't type this in the calculator right. Okay, those of you that asked for 5, that's enough.
H plan.
Okay. To try to find a good stop in place here. Number 6, I did put my answer up there. Also make sure, even if you're not to question 6, that you write down that formula. This is volume of a sphere is not one they expect you to memorize, but for you to be able to finish this up, you might need it, and you do need it for question 6, so make sure you add that to question 6. Okay, yeah, and this only had 12 questions, so I would like you to please try to finish this up so you can see if anything else is going to give you any issues. But we will practice more related rates next class. Okay, so I'll put the agenda back up here in a minute, but I do want you to finish 34. And if you want to keep working on that, as always, that's fine. You still got 10 minutes, but I will also let you try the puzzle for today if you'd like. Okay, we did this one yesterday. Okay.
You just flip it upside down. When gravity will Oh, I got it. This one. like this. This one. But then, take this one. I got it.
That?
Creatine's working.
You got it despite the creatine.
Do you have to find all of these separately?
1/3 area to base times the height. Okay, so right here, this capital B, just put pi r squared. You don't have to do a whole separate thing over here. I would just put pi r squared right there. So then you've got pi over 3 as a number. That's just going to carry down the pi behind everything. And then when you try to take the derivative of r squared h, you're going to have to do product right there. See right there, you can't. It's hard for you to see, but you're not doing product, right?
Oh, yeah.
So that's part of what's throwing you off. Yeah, I'm really bad at these. I only know how to do this one because someone told me.
But the way I did it would work if I used a regular flip it, because I found the regular.
It should,
base
yes.
would-
In theory, it should. I don't know that it's going to be about the same difficulty or not. It might be a lot harder.
That's the balance in that.
Anybody enough of a Hog fan to think they're going to win this weekend?
No.
Tennessee. They're number 4.
I mean, any upset can happen. I don't think it's gonna happen though.
Yeah, but y'all are supposed to be believers.
It's hard to believe.
All I know is that we're gonna play them to their level and then lose anyways.
Yeah, that's the Arkansas way.
Yeah. I think that's just like Sam Pittman. He plays to teams at a level and he either, or if the team is better than us, he plays to their level before losing. Like the fourth quarter. Happened last year against Alabama.
Oh, I don't remember that at all, but
Yeah, we're actually pretty close last year to Alabama.
for like what, 3 plays or something?
No, like till like the fourth quarter.
Oh.
I just want this season to be over so Bobby Petrino will be our head coach again.
Yes.
You still got the same players. You're still going to be running the same offense. I've heard that rumor too, but I don't know. Huh?
Gonna be Bobby Petrino or Barry Odom.
Well, if we have a great year,
Pittman's going no matter what.
No.
not if we have a great year.
Yeah.
It's looking rough for a great year.
Well, I didn't say we were going to have one. But if we have a bad year, doesn't that also look bad on Petrino?
Not as much as.
No, that's bad on Sam Pittman.
Pittman's letting them run the whole offense, isn't he?
I mean, technically our offense has been the worst struggle so far.
Yeah.
And Petrino's the coordinator.
Maybe Petrino gets fired and Pittman doesn't.
Barry Odom comes though, and Barry Odom is our head coach. Coach Dick will probably leave and go coach there.
Oh, then we're screwed. UNLV is 5-0.
I'd be curious to try Barry Odom, but he didn't exactly do too well the last time he coached an SEC team. I mean, it was just kind of mid. It was around Sam Pittman level. And then he got fired from Missouri because of that.
Are you guys too young to remember Houston Nutt? We could bring him back.
Is he like 80 or something now?
I don't know.
Also, I think he showed that he couldn't coach anymore when he went to Ole Miss and involved
He's 66 years old.
Dang, that's younger than I thought.
He's coach Dick's coach.
Alright, we've got just a minute. If you got one of my calculators, I need it back.
Houston Nutt gave us a pregame